All right, so I'm going to go through an example, a practical example of how to do both the direct capitalization approach and a discounted cash flow approach using Google Sheets. So there's a copy of this sheet available on online, and if you want to sort of utilize it, just go to File and make a copy. And then you can have a copy that's editable directly and stuff. You can't edit this copy that I'm working on because if we all edited it, then we'd all be just writing over each other's work. So just go to File and then make a copy. And then you can work on and use this as a template. But with all methodologies, we have some starting parameters to work with for the income approach. And what we're going to do is look at an office property in San Francisco. That's our region, and a couple things of interest. One is going to be the consumer price inflation, because we're going to use that for estimate of rent growth. And long-term consumer price inflation, 2%. Obviously, it's very different right now at the time of the recording, but let's say 2% for our assumptions here. And then cap rates for this market, these are Class A properties, meaning it's like a really nice building, 4% for this market. And then discount rates, remember, which are higher than cap rates because they include estimates of kind of total return, whereas cap rate is more about dividend yield. Discount rates in this market are 7%. So let's just assume that we found these via looking at comparable properties. And then these are the numbers that we've reconciled to. With these assumptions, we can go back and reference them when we build our spreadsheet for both the DCF approach or the direct cap approach. So I'm going to walk through each one of these. So just hang on a sec. Let's start with a DCF approach first. Here is our property name, Presidio offices, down in the Presidio, Class A office space, very nice, very in demand, beautiful neighborhood. And we're just generally going to call that the Marina. I mean, I know it's Presidio, but proposed purchase price, $6.5 million. But what we've been asked to do is actually value whether that's a good price or not. Bank wants to know what it's actually worth. Maybe that's what it's going to be sold for, but we kind of need to know fundamentally what it's worth, whether the buyer's in their right mind, that sort of thing. So what we're trying to do is come up with an estimate of value under the DCF method and also the direct cap approach. And to do that, we need to input the property's financials. DCF approach first, we're going to assume a 10-year holding period. And what we do is we go out and get potential gross income on the property, remembering that assumes that this property is fully rented without any vacancies whatsoever. So everything is just 100% rented. And maybe right now we see that year one income is estimated to be $400,000 based on the previous year's income, $400,000, and then we assume that rents are going to increase by 2% each year. And you see a formula happening here up above here. We're referencing back. We're saying year two rent is going to be equal to year one rent, B9, multiplied by B3 in our assumptions worksheet. So if we go back to the assumptions worksheet, B3 is this 2% inflation. So rents are adjusted, it looks like, according to inflation of 2%. It looks like kind of a step up. We could say it's indexed inflation, or indexed leases here in this case, or more technically, it's going to be whatever is inflation at that time is what the rent amount is going to be adjusted by. Here, it's sort of like locked in expectations of inflation. And so these are step up level increased amounts of 2% each year for the horizon. By the way, you notice these like dollar signs in between B and 9 in both Excel and Sheets. What that does is lock what how do I say this? It locks when you transfer something over. So you see this thing here, if I want to drag this and then copy that formula over, if I didn't lock it, if it was just B9 instead of $B, $9, what's going to happen is it's going to break. Well, it's not going to break, but it's going to go to C9, and C9, I don't even know what that is. C9, oh, right. It's going to go to C9 here on this spreadsheet. So it's going to go to this previous year and then multiply that by the assumptions in B3. So if we don't want that, if we all want it to be relative to the year one, we want to keep referencing back to this cell instead of this cell. We have to lock it. It'll be, and the dollar signs will like lock it over for us. So then when we drag it like that and then copy that formula over, we see it's still B9. Okay. All we're doing here is just estimating potential income, potential gross income, and then the next step is to subtract out vacancies. And vacancies, we're just going to assume 5% here, 5% each year, and then that's not going to change. And technically it should be 5% of that year. So in this case, I can say equal this times 0.05. And in this case, I don't want to use that dollar thing. I'm just going to have this dragged over, and then vacancies will adjust so that it's a function of that year's income, potential gross income. Add back any miscellaneous income. In this case, there's no miscellaneous income. So subtracting out vacancy, our effective gross income is here, just that minus that. And then after effective gross income, we had operating expenses, subtract them. And I'm just gonna group fixed and variable together. So we've got property insurance, that would be considered fixed. Garbage would be considered variable. And I just kind of made up this data. You can see it's a percentage of vacancy. Vacancy, potential gross income, or effective gross income. And then after operating expenses come capital expenditures, replacement for roof, something like that. In this case, there's some money over the next 10 years set aside for capital expenditures, 200K, and then we just sort of level equivalently turned that into $20,000 a year. So money set aside that needs to be set aside for major capital replacements over the next 10 years. And take effective gross income, subtract out operating expenses, and then subtract out capital expenditures each year. That's our NOI for each year. And one final thing we need to do in the DCF approach is that, we hold it, we buy it now, hold it for 10 years, but it doesn't just go off the face of the earth after 10 years. After 10 years, we sell it. And so we need to estimate what this thing would sell for at the end of 10 years in order to complete the DCF approach. We call that expected sale price at the end of this horizon. We call that terminal value. Terminal means end, and so terminal value, the ending value. And the way we're going to get that is through the direct cap approach. What we're going to do is take year 10 income, or year 10, actually we would take years 11 income, so year 10 times a growth rate, assuming that year 11 grows at the same rate, rents in year 11 grows at the same rate as the previous years, that 2%. And that estimate of year 11 income divided by assumptions B9, our cap rate, gives us the estimate of sale price of 9.7 million at the end of year 10, based on the expected year 11 rents. So we actually use the direct cap approach inside of the DCF approach for the purpose of getting terminal value. And then we add all those cash flows together. So years 1 through 9 are just basically we're taking NOI. And then year 10, what we're doing is taking year 10 NOI plus the money that we received from selling at the end of year 10, that 9.7 million we just calculated. Sum of those two together gives us our 10 million cash flow that we're going to receive at the end of year 10. And then this row is all we need at this point to do the DCF approach. We need this and some sort of present value factor to bring these cash flows into today's dollars. And our assumptions were that discount rates, this is going to be our present value factor for real estate investors in this type of property market, is 7%. That's sort of like their hurdle rate, their rate of expected return, that sort of thing. This is what we're going to use as a present value factor to convert these cash flows into today's dollars. And what we get is this number, and how we get it, we're actually going to use Google's net present value formula. We're not actually calculating net present value here. I'm sorry for the confusion, but for Google Sheets, and actually for, I think, Excel as well, if you have level payments where it's like, $200,000 every year and that doesn't change, those are level payments, then you can use the PV function. But if you have non-congruent cells that are not next to each other, or you have payments that vary, you need to use the NPV function, at least in Google Sheets. And so what we're going to do is specify the discount rate first. What we're doing there is referencing back to this discount rate for Class A properties. And then we can just select our cash flows. So the way you do it, equal NPV, then you go and without clicking anything else, you just click on discount rates, press comma, then you're going to go and select your cash flows. And then I just drag and select the cash flows in order of year. And that's all you need. And that gives us our value of today's dollars of 7.415 million. So this is our estimate of value under the DCF approach. And so for the direct cap approach, it's simpler. We really just ignore all the stuff we did and we just look at year one. So we just look at year one information. Remember, direct cap, we take the first year NOI, divide it by a cap rate, and then we're done. And that's what you see here. You see B30, which is this year one NOI, and then divided by the cap rate in our assumptions page of that 4%. Let me just make sure that that's B9. B9. Yes, it is. It's just that's B9. Yeah. And in this case, they're not too far off. The direct cap approach and the DCF method are fairly close to each other. I mean, that is almost $500,000, but as a percentage of the sale price, it's still less than 10%. Sorry, as a percentage difference between the two, it's still less than 10%. So we're reasonably close. Where we start to get differences is if you have major differences in income over the subsequent years. So if year 5, suddenly we expected things to grow at a much higher rate, the more that they grow, the greater the deviation you start to see between the estimate of value under the DCF approach and then the estimated value of the direct cap approach. So big differences can occur between these two methods when things about your property are expected to change over the coming years. If year one is not a reliable estimate of what's going to happen for the remainder of the holding period, then you need to start thinking about using the DCF method. Your direct cap approach is not going to be a realistic approximation of what's going to happen in real life. And I also just wanted to touch on one thing, just as a practical note. It's not something we talked about in the slides. So far, we've talked about only getting an estimate of values. So this is for us as our investors, as appraisers, as brokers. We're trying to get a read on what this property is actually worth. But oftentimes as an investor, I mean, let's say you work as an analyst for a REIT and you specialize in basically buying different big buildings and adding it to your REIT. You want to look at the net present value. You want to look at what additional value, if you can get it at the sale price, what additional financial benefit that gives you over and above your cost of capital or your hurdle rate. So, you're looking at NPV a lot as a buy-side analyst. And the way you do that here in this setting, this is actually, this is the way a financial analyst would do it as an investment banking analyst for valuing companies. It's the same idea. Is that you model what this company, or what in this case this piece of real estate, is worth to you fundamentally based on financials and expected financials and costs and all that. You get a present value to figure out what's that worth to you in today dollars based on your discount rate. And then you compare that to what you can actually buy it for, the purchase price. And if your estimate of value is significantly above what you can actually buy it for, that's great. And the difference between those two is actually what net present value really is all about. That's what NPV is. So you can calculate an NPV by taking your estimate of value minus the cost to actually buy it in the market. And we all know what we say about positive NPV projects. It looks like this one's a go. So this is how you would use financial modeling to make an investment decision on whether to pay or how much to pay. At some point, let's suppose we get into a bidding war and there's another bidder. They're offering $7 million. Should we match or should we just walk away? Well, we can see what happened at the NPV dropped by a couple $100,000, but it's still positive. It still makes sense to at least match. In fact, we might go all the way up to something close to, we might even up it. And it's just at that point beyond 7.415 thousand, we'd start entering into the zero NPV territory. So we probably wouldn't want to bid more than 7.4 million, but we'd be prepared to bid anything up to that if we got into a bidding war. So it's just kind of a useful way you can actually use these sheets to not only figure out what a good price to pay is, but also a maximum price to pay.